next slide, we will see the manufacturing consideration or design consideration for a particular manufacturing process. Suppose your product, your component is to be manufactured through casting. So you need to consider some points regarding the casting method. Means it means only it gives you some way insight to design your product in such a way that the casting would be easy if it is necessary. So let's understand how the design consideration for a product which has to be manufactured through casting. So first is design parts to be compression, then intention. As we all know that the casting product are generally very generally have very high strength in compression rather than in tension. So while you are designing a component which is to be manufactured through casting, should be designed for compression, not for the tension. And suppose if its parts it's some parts or it has to be used in tension situation, then you should strengthen it by adding some external devices. So that is another point which you should consider. These 2 points, I think, first 2 points. The next point is shape of casting for orderly solidification. In casting, solidification is very important. If your solidification is not done properly, then your casting may have some defects that should be avoided. So if you, and again, if your shape is very complex, then obviously molten metal may not flow inside that particular complex shape, and your part ultimately could not be solidified easily, or it could not be in proper shape. So you have to make casting design for a particular product which are you are thinking in such a way that it should have some orderly or some uniform solidification. So that should be considered. Next one is avoid abrupt change in cross section. Means your design should be in such a way that it should not have abrupt changes in design. Abrupt changes means sudden changes in the dimensions, sudden enlargement of the diameter, or sudden contraction of the diameter. That should be round of the corner. Suppose it has sharp edges, it should be rounded off. Means otherwise your casting will have stress concentration that should be avoided in any case. Next one is avoid concentration of metal at junctions. Suppose there are some junctions where metal is to be fused, and you should avoid extra metals there. Otherwise, it also leads to the stress concentration and bulky sense to the component. That should be avoided. Next point is avoid the thin sections. In casting, while you are designing a product in casting for casting methods, then you should avoid thin sections because it will be weaker in any case. So next one is make provision for easy removal of the pattern from the mold. Obviously, I think you should have some idea about the casting. In casting, there would be a pattern of desired shape, and that is used to create the cavity, and in that cavity molten metal is poured and gets solidified, and ultimately after solidification you'll get your component. But while you are designing, you should be pre-consider the easy removal of the pattern, because pattern is obviously, if pattern is not properly removed from the cavity, it will distort the dimensions, it may damage the cavity, and that will ultimately lead to the non-accurate, means it would not get you the proper shape of the component. That should be avoided, I think. So while if you're designing a component which has to be undergone for casting process, casting method of manufacturing, then you should consider these points and try to try to careful about these points while you are considering. The next is design consideration in welding. So welding is another process where two components are joined or two parts are joined permanently, and if you are using welding method, then you should consider following points. Use minimum number of possible of belts, means number of belts should be very minimum, otherwise obviously you should avoid the large number of welding spots, because these spots damage the I think material due to the heat affected zone, and it will also lead some complications. Next point is select the same thickness of for the part to be welded together. Suppose two components are to be welded, then they should have similar dimensions, otherwise uneven structures may be resulted. So that would also lead to stress concentration. Next point is locate the belt at the areas or the design where stresses and deflections are not critical. So obviously it is additional part, means belting should be done, try to done belting where stress concentration is not very critical and deflection is not very critical. Next point is effect of shrinkage and distortion should be minimized by the post welding annealing and stress relief operation. That are the welding consequences, means if you are going to weld something, you should need to prepare it first, and annealing and stress relief operations are very important pre and post operations of the welding. Means after welding you need to perform annealing process, stress relief operations, so that stress may be residual stress may be removed from there, otherwise it may distort the shape of the component. Next one is decide proper welding sequence. Welding sequence should be proper, it should be in a logical manner, otherwise it may also lead some complications. Next point is design welding in flat or horizontal position, not in overhead position. Try to get a flat or horizontal position, means on the ground you have to weld it. Overhead weldings are, if it is required, then you can do it, but try to avoid it. Next